Let's simplify 8x to the negative 1/3 minus 2x to the 1/3. I'm going to factor out the greatest common factor. So between 8 and 2, I'm going to factor out a 2. And between x to the negative 1/3 and x to the 1/3, I'm going to factor out x to the negative 1/3, so x to the least exponent, or the smaller exponent. Then I'm going to put parentheses and figure out what's left over after I factor that out. So if I factor out a 2 from 8, I have a 4 left over. And I factored out all of x to the negative 1/3. From the second term, I factored out the 2, so I still have minus. And then if I factor out x to the negative 1/3, what's going to happen is I'm going to have x to the 1/3 minus negative 1/3. So when I factor that out, I'm going to be subtracting that exponent. So in the next line here, I have 2x to the negative 1/3 times the quantity 4 minus x. And now the new exponent, 1/3 minus negative 1/3, is 1/3 plus 1/3, which is 2/3. And finally, to fully simplify this, I don't want that negative exponent, so I'm going to bring down x to the negative 1/3 to the denominator. The 2 is going to stay in the numerator. That is not attached to the negative exponent. So I have 2 times the quantity 4 minus x to the 2/3 all over x to the 1/3. Now let's simplify this expression. I have x times 1/5 times the quantity 2 minus x to the negative 4/5 times negative 1 plus the quantity 2 minus x to the 1/5 times 3x squared. Now, there is a lot going on here, but there really only is just two terms because terms are separated by addition. So we want to go ahead and look for the greatest common factor between the two terms, starting with the numerical factors. So in the first term, that would be 1/5 and negative 1. And if I look at the second term, that would be a 3. And there's nothing in common between those numerical factors. Move on to the variable factors. In the first term, we have x cubed. In the second term, we have x squared. So what we can factor out there is x to the least exponent. So we're going to factor out an x squared. And then we move on to binomial terms. So we have a 2 minus x, all in parentheses, to the negative 4/5, and a 2 minus x, all in parentheses, to the 1/5. So we can factor out that binomial 2 minus x to the smaller exponent. That would be to the negative 4/5. And then we'll take a look at what's left over. So from the first term, I have the numerical factors of negative 1 and 1/5. So we'll put those first. We have negative 1/5. Then we factored out an x squared from x cubed, so we have an x. And we factored out all of the binomial quantity 2 minus x to the negative 4/5. From the second factor, we have the numerical factor of 3, so we're going to have plus 3. We factored out all of x squared, and the binomial factor, we're going to have the quantity 2 minus x to the 1/5, but we factored out, so we're going to subtract negative 4/5. All right, so now in the next line we have x squared times the quantity 2 minus x all to the negative 4/5 times the quantity negative 1/5 x plus 3. And then I have the quantity 2 minus x, and if I add 1/5 minus negative 4/5, that's going to be 1/5 plus 4/5, which is just 1. And so now, inside this last set of parentheses here, I can distribute the 3 in, so I'm going to have x squared times the quantity 2 minus x to the negative 4/5 times the quantity negative 1/5 x plus 6 minus 3x. And in this factor now, I have some like terms. So I have negative 1/5 x minus 3x, so I can add those coefficients. So I have x squared times the quantity 2 minus x to the negative 4/5 times, so negative 1/5 x minus 3x, well, I can think about negative 3x as negative 15 over 5x. So adding those coefficients, I get negative 16 over 5x plus 6. So now from here, I'm going to go ahead and move the factor of 2 minus x to the negative 4/5 to the denominator so that I don't have a negative exponent. So I have an x squared in the numerator, the negative 16 over 5x plus 6 in the numerator, all over the quantity 2 minus x to the positive 4/5. Now we're almost done here, but we really don't want a fraction inside of a fraction in the numerator. So in order to get rid of the 16 over 5, I'm going to clear fractions by multiplying the numerator and denominator by 5, since that's like multiplying by 1. And then I'm going to distribute the 5 into the factor over here that involves the fraction negative 16/5. So I'm going to distribute that in, and I will be left with the x squared in the front, negative 16x plus 30, all over 5 times the quantity 2 minus x to the positive 4/5. And now I can even see that between these two factors here, I can take out a 2 or even a negative 2. So that would leave me with negative 2x squared times the quantity 8x minus 15 all over 5 times the quantity 2 minus x to the 4/5. Let's simplify the quantity x cubed plus 1 to the 2/3 times 2x minus x squared times 2/3 times the quantity x cubed plus 1 to the negative 1/3 times 3x squared all over quantity x cubed plus 1 to the 2/3 squared. There is a lot going on, but I want to focus on the fact that in the numerator there are just two terms. Terms are separated by addition, and subtraction is really just addition of a negative. So we have two terms. Now, first things first, I want to recognize that I cannot cancel one of these binomial factors here, like x cubed plus 1 to the 2/3 and one of these x cubed plus 1 to the 2/3 in the denominator right now, because I don't have all factors in the numerator. I have two terms. I would need to create it so that it's all factors, everything up here being multiplied. So that's what we're going to work on. We're going to work on factoring the numerator. Well, in the second term, there's a quick little simplification I can do. If I look at the numerical factors, 2/3 and 3, I have that 3 divided by 3 is 1. So I can go ahead and cancel that out. And then let's go ahead and see what we can factor out that's in common in both. Looking at the remaining numerical factors, I have a 2 in the first term and a 2 in the second term, so I can factor out a 2. From the variable factors, in the first term I have an x to the first. In the second term I have an x squared and an x squared, so an x to the fourth. So I can pull out the smaller of the two, which is an x to the first. And from binomial factors, I can take out the binomial factor x cubed plus 1, but it's a matter of to what exponent. So we have x cubed plus 1 to the 2/3 and x cubed plus 1 to the negative 1/3. I can pull out the smaller of the two, so x cubed plus 1 to the negative 1/3. Now let's go ahead and see what is left over. From the first term, I took out the 2, the x, and now I'm taking out this x cubed plus 1 to the negative 1/3. So I have x cubed plus 1 to the 2/3, but we're taking out, so we're subtracting negative 1/3. Well, notice 2/3 minus negative 1/3, that's 2/3 plus 1/3. That exponent right there is really just a 1. Now we have minus from the second term. I factored out the 2. I took out 1 copy of x, but there were 4 copies of x. I had x to the 4th total, so I'm going to have an x cubed left over. And then I took out all of the binomial x cubed plus 1 to the negative 1/3. So I really just have an x cubed. And then all over, in the denominator, I'm going to write this as x cubed plus 1 to the 4/3. I can multiply the exponents 2/3 times 2. Now I'm going to write this as 2x times the quantity x plus 1 to the negative 1/3 times, well, in here, this is really just x cubed plus 1, because it's all to the first power. So this is really just an x cubed plus 1, and then minus x cubed. So kind of a nice thing happens, right? X cubed minus x cubed is 0, and so all I really have left there is 1. And then all over quantity x cubed plus 1 to the 4/3. So now, I don't want this factor to a negative exponent in the numerator, so I'm going to rewrite this as 2x in the numerator. I'm going to bring down the quantity x cubed plus 1 to the 1/3, making it a positive exponent, but there was an x cubed plus 1 to the 4/3 already down there. So we can go ahead and add those exponents together. 1/3 plus 4/3 is 5/3. So I have a final answer of 2x all over the quantity x cubed plus 1 to the 5/3.